Hello, am I audible?
Yes, sir.
Okay. So in the previous class, we discussed some operation amplifiers and two important parameter. One is the input resistance, Rin, and second is the output resistance, Rout. Okay. Along with that, we discuss the negative feedback of op-amp. Along with this, we discuss why positive feedback is not used. Okay. Along with that, we discuss that how to identify the terminals of op-amp. Okay, now we discuss some other parameters. Infinite open loop. Okay. Generally, ideally, what we consider that an operation amplifier has infinite open loop gain. What is the meaning of this one? If we are saying that this is my operation amplifier, there is no feedback. So the positive terminal, negative terminal, we say the V1 voltage, V2 voltage. This one is grounded. Source, resistors, and this is okay. This is called the RIN. Generally, what we consider that both the terminal are working on a same potential. That means when you are going to solve this one, you consider that V1 is equal to V2 due to virtual ground condition. Okay, due to virtual ground condition. What is the meaning of virtual ground condition? Basically, in electronics devices, what we do, we connect one battery, one resistor, and all are connected with the grounded. Okay, this is the basically ground symbol. So what we assume, we assume the potential or the voltage at this point is zero. This is not exactly zero, but we consider that the potential or voltage at this point is a zero. This is called the virtual ground. This is called the virtual ground. Okay, and this virtual ground will be having that the potential at this voltage at this point and potential at this point will be zero, same or zero. Okay, if we are connected with the grounded, if I connect this one with the grounded, so voltage at this point is zero. So similarly, the voltage at this point is also zero. Okay, because both are the voltage are same. So we consider that when we are solving, we consider that V1 is equal to V2 due to the virtual ground condition. And if V1 is equal to V2, that means the voltage drop across R in is also zero. Okay, V R in is also zero. Why V R in is zero? That means if voltage at this point and this point is same, that means no voltage will be drop here. No voltage will be drop here. If I connect a 5-volt battery here, okay, so this point is the 5-volt. Similarly, this voltage is 5-volt. That means same voltage will be travel from here to here. That means no voltage drop here. So V R in is zero. Okay. If V R in is zero, so that means this particularly voltage source, that is A times V R in, is also zero. What is the gain? Anything? The gain will be multiply with zero. It is a zero. Now, if V R in is zero, that means the current coming I out is also a zero. Okay. This is we are taking in the ideal case. Now, if I out is not equal to zero, so that means V R in is zero, but A times V R in is not equal to zero. A times V R in is not equal to zero. So in that scenario, what we assume that A should be infinite. A should be infinite. So that's why we call that the infinite open loop gain. Okay, infinite open loop gain. So op-amp ideally has an infinite open loop gain, but practically the gain value will be something very high, that is 10 raised to power 5. So ideally A is infinite, but practically A is 10 raised to power 5. Okay, so this is a one more important parameter about the operation amplifier. Now, bandwidth. We discussed the practically operation amplifier in the week 7. When we are going with the week 7, so we discuss the practically or basically non-ideal operation amplifier. So here you discuss the this particularly amplifier gain as well as the bandwidth as well as the so basically the amplifier operation amplifier gain is defined as a is equal to a naught 1 plus j omega upon omega naught, or a naught 1 plus s upon omega naught. What is the meaning of this one is that if we are using any particularly component, every component is dependent on a frequency, and that frequency is the omega. This omega naught is cutoff frequency. Now, op-amp only shows the response similar to LPF. What is the meaning of this one? If it shows the response of operation amplifier, so initially this will behave as a normal. After a certain frequency, it will be the response is completely changed, like this one. And this particular frequency is called the omega. Okay. Practically, sorry, ideally, the value of omega naught is infinite. Ideally, the value of omega naught is infinite. That means there is no cutoff frequency. Operation amplifier will behave similar for all the frequency range. Okay, but it is not possible. Omega amplifier operation amplifier op amp will also behave a similar response up to a certain frequency, and after that the response will be changed, like similar to the diode and transistor. I am not sure that you are using the diode and transistor characteristics or not. Are you aware the diode and transistor characteristics? Yes, anyone? Are you aware with the diode and transistor characteristics? Am I audible?
Yes, sir.
Okay. So are you aware with the diode and transistor characteristics? No. Diode VI characteristics? Have you studied the diode? Okay. So every electronic component will behave or shows their response up to a certain frequency. After that particularly frequency, the response will be changed. Similar to the operation amplifier. Ideally, the cutoff frequency will be the infinite, but practically it is not infinite. It is up to a certain frequency. After that frequency, if we show the response of the operation amplifier, that is completely changed. Okay. So ideally, omega naught is infinite. So when I put the omega naught is infinite, so A is equal to A naught 1 plus S upon infinite. So that is the A naught. Simply gain. This A naught is not dependent on any particular frequency, but practically a non-ideal case, the gain of operation amplifier is A naught upon 1 plus S upon omega naught. Okay. So if We discussed the ideal operation amplifier. It shows the infinite bandwidth. But if practical operation amplifier, the bandwidth is omega naught and gain is a naught upon 1 plus s upon omega naught. A naught upon s plus 1. Okay, so these are the certain parameters about the operation amplifier. If you have any doubt, you can ask me. Question, example, identify the terminals. First and second, find V out if V in is 1 volt. Just identify the terminals. Anyone identify the terminals?
So it's a negative feedback.
Yeah, negative feedback.
So then input is a positive terminal.
This one is a positive terminal. This one is negative. Is it correct? Yeah, everyone, please. This is correct or not?
Yes.
Okay. So basically, no effect of this second operation amplifier. Okay,
And
every
so the
individual
output
operation
volt,
amplifier will be the negative feedback. And what is the output
and
voltage?
so 12 volt.
12 volt. So if I say this is the V out 1, so what is the value of V out 1?
So 3.
1 plus RF by R1 time V in. So 1 plus 2 by 1 multiply by 1 volt. That is the 3 volt. Now what is V out? V out is again 1
12.
plus RF by R1 time V out 1. 1 plus 6 divided by 2 times 3. So it is a 12. Identify the terminals and find V out voltage. Just identify the terminals.
Positive for 1 volt.
Positive for 1 volt and negative for this one. And what is output voltage? Yes, what is output voltage?
Maybe 21, sir.
21. Okay. Any other? Any other output voltage except 21?
$28.
20. Okay. Any other?
So 4 volt.
4 volt. Okay. Any other? Okay. So, so basically, if you are watching this circuit, so first of all, we identify this is my RF. Now, what is R1? The point to understand here is the what is value of R1. Yes, what is the R1 for this operation amplifier? Okay. Now it is initially before starting of this class, we discussed that op-amp in negative feedback behave as a virtual ground. Is it clear? So what is the meaning of virtual ground? That means the voltage at this point and voltage at this point is same. Okay. If voltage of both the point will be same, no current will be going inside this one and no current will be leaving out this one. Okay. So no current will be going this side and no current will be leaving this one. So that means the current in this direction is zero. Similarly, the potential at this point and potential at this point is zero. That means no current is going inside. So the current in this direction is zero. Is it clear? Yes, it is clear. Now the current that is coming from the V out, it will be coming in this way. Now at this point it will be distributed in this one and in this one. Current in this direction is zero. Current in this direction is zero. So that means current will be distributed in these two resistors. So I can say that these two resistors are parallel. So 1K is in parallel with 2K, and that is input resistance RIN. Okay, so your formula V out is equal to 1 plus RF divided by RIN into V in. You are getting the V out 1. Okay, and V out is 1 plus RF divided by RIN times V out 1 is your overall V out. Okay, now you can calculate what is the V out. Any doubt?
So can you explain it again?
Okay, basically in the starting of the class I discussed that okay, this is the virtual ground condition. Okay, basically operation amplifier in a negative feedback always behave as a virtual ground concept. So if operation amplifier is working in a negative feedback, that means there is a virtual ground will be active. Only in the negative feedback, not in the positive feedback. In the week 3 we discussed the positive feedback, but in that situation we are not taking the virtual ground concept. We are only taking the virtual ground concept for the negative feedback. So first of all, we identify that my operation amplifier will be behave as a positive feedback or negative feedback. If it's behave as a negative feedback, apply the virtual ground concept. Okay, and what virtual ground concept says that the potential V plus and potential at this point V minus both are same. So V plus is equal to V minus. Okay. And if V plus is equal to V minus, that means the current going inside, this is 0. Clear? Any doubt?
So, sir, why this concept is not applied in the above question? That was also in negative feedback, no?
Yeah. This one,
Yes, sir.
we are taking always the I is equal to 0. In this one is I is equal to 0. In this one I is equal to 0. That's why we are consider this is my feedback path, na? And the amplification gain will be provided because of this one.
Okay, there is means this say circuit have its individual input voltage, input resistance.
Yeah.
Oh, okay,
Basically,
okay.
both circuit are individual. In this particularly scenario, both circuit are individual. The feedback of this particularly is not dependent on the feedback of this one. Okay. But right now, this is a complete loop. This loop is complete. So first, both particularly operation amplifier will be connected. These are not an individual circuit. If you break a loop, if you break a part, so you can't say that your operation amplifier first will be behaving as a negative feedback. Why? Because there is no feedback. When the feedback appear, the output of the second operation amplifier will be going as a feedback of the input of the first operation amplifier. Clear?
Yes, sir. Yes, sir.
So we are taking the virtual ground condition. That means the current inside is 0. I is 0. If current inside is 0, so that means the current that is coming from the V out as a feedback path, it will be passed from the 6 kilo ohm and then it will be distributed between the 1 kilo ohm and 2 kilo ohm, because there is no different path. If the current is not 0 here, if the current is not 0 here, so we can't say that these two are in parallel. Okay, because current is distributed at some other point also. But now the current in these two branches will be 0, so the current, whole current will be distributed in 1 kilo ohm and 2 kilo ohm. Now we can say that these two resistors will be the parallel. So overall Rin is what? 1 kilo ohm and 2 kilo ohm parallel combination. Okay.
Yes, sir. And so while solving the graded problems, I got a concept that is open circuit loop gain and closed circuit loop gain. Can you explain that?
Yeah. Okay. When we are going with the feedback, I am taking a feed. This is the amplifier A. It will provide me the output. We are taking the feedback. Beta. my input V in and this is the VE error plus and minus. Now what is the meaning of open loop? If I break this one from here, so that means no feedback. If I break this circuit, that means no feedback. So V in is equal to V and V out is equal to A time VE. Now if I put the V is equal to V in, so we can say the V out is equal to A time V in, and V out upon V in is what? A. That is called the open loop gain. Okay, that means there is no loop, so we can say this is the open loop gain. Now if we are talking about the closed loop gain, so we already discussed that V out upon V in is what? A upon 1 plus A beta. In the previous class we discussed this one. So that is called the closed loop gain. Okay.
Okay, sir. So, sir, how do we know where to apply closed loop gain and where to apply open loop gain?
If in a question
Any
it is given according to the circuit, like for example, if we are talking about this particular circuit, okay. So if the feedback is available every time we are using the closed loop gain, this is the feedback. If feedback is available, we are using the closed loop gain. We have to solve it. The V out upon V in is 1 plus RF by R1. This is the closed loop gain. Okay.
yes, sir.
It is mentioned properly in the question that we have to use the open loop gain or not. If in the question it is not mentioned, we are always consider, or after watching the circuit, we realize that if it is a loop, so we are using the closed loop gain. Clear?
Yes, sir.
Any other points? Any other doubts? Last question. Find the way out. Yes, what is the output voltage?
So 15.33.
15.33. Any other answers? Someone mentioned 15.3. Okay. So basically, if we solve, see, the question is very simple. We have to take the formula V out is equal to 1 plus RF by R1 times V in. Okay. Now the RF is the parallel combination of two resistors. So 20K parallel with 40K. Okay, so it is a 80K divided by 60 or 40K divided by 3. So V out is 1 plus 40 divided by 3 into R1 is 2 times 2. So it is a 23 times 2 divided by 3. So 46 divided by 3. 15.33 volts. Okay, so just remember that if we are using a non-inverting amplifier, non-inverting amplifier, my gain is 1 plus RF by R in or R1 times V in. And what is the meaning of non-inverting amplifier? The applied input voltage at non-inverting terminal. Okay, just remember this thing. Till now, we only discussed the non-inverting amplifier. In week two, we discussed the inverting amplifiers. Then after inverting and non combination of inverting and non-inverting amplifier, we will discuss in the week two. Okay. So that's it from my side. If you have any doubt, you can ask. No doubts?
No, sir.
Okay. So thank you all.